Hello, bonjour, it's Laura here. In this video, I'm going to talk about how to go about balancing equations. So the first step in balancing equation is you need to read the description of the reaction and then write what the reactants are in the products, and you also need to know their states. So you write the appropriate formulas and then the unbalanced equation. So for example, here we've got methane gas and oxygen gas reacting to form liquid water and carbon dioxide gas. So you take all of these formulas and write them into a chemical equation. So you want to have your reactants on the left, your products on the right, your states beside each of them in brackets, and then you also have your arrow there. Okay, great. So now the trick is to make sure that you know whether you have a balanced equation or not. So this is where I like to do the tally. So here we've got our reactants on the left, so we'll count them up. It looks like we've got 1 carbon, we've got 2 oxygens, and then we've got 4 hydrogens. And then in the products, again, we've got 1 carbon because it's unwritten, so it means 1 there. We've got 3 oxygens because we've got 2 here and 1 here. And then we've got 2 hydrogens. So you can see that our carbons are balanced, they match, but our oxygens are not. We've got 2 on the reactants and 3 on the products. So that's not balanced. Also, the hydrogens are not balanced. We've got 4 on one side, 2 on the other, so those are not balanced. All right, so what do we do about that? Well, we need to experiment with putting coefficients in front of the formula for these different compounds. Remember, we can't, the big rule is that we can't change the subscripts. That would completely change the actual compound, but we can change the coefficient in front. So we don't need to do anything with the oxygens, or I mean the carbons. What about the oxygens? So we've got 2 on one side, 3 on the other. What could we do to change that? And think about what could we do to change these hydrogens. So the hydrogens might be easier for us to work with, because with the oxygen we've got 2 compounds giving us oxygen on our product side. So let's work with the hydrogens first. So we've got 2 on the products, 4 in the reactants. What could we do to change the products? So what I could do is write a 2 in front of the water, and then what that does is give me 4 hydrogens here, right? Because we've already got 2 in the molecule, and if we have 2 of those molecules, we have 4 altogether. So how does that change our oxygens? So now we've got 1, 2, 3, 4 on our product side. So we've got 4 oxygens. Okay, so we're not balanced with our oxygens still. So can we do anything on our reactant side? And yes, we could. We could put a 2 in front of the oxygen there, and then that'll give us 4 altogether. Okay, and so there we go, our equation is balanced. So it's a bit of trial and error, working with the simpler compounds first. So notice I went with the hydrogen first because there was only 1 molecule contributing to hydrogen on either side, so I could manipulate that more easily than the oxygen. Okay, so that's how you do it. Writing the coefficients in front. And then the next thing is to make sure that, just check, make sure that the coefficient gives us the same number on each side. So we can do that. I've got, checking my carbons, I've got 1 here and 1 here. I've got 4 hydrogens, 4 hydrogens, 4 oxygens, and 4 oxygens. So again, I'm balanced. And then check that our coefficients are in the smallest integers, so the lowest terms. So we've got unwritten 1 here, we've got 2, 1, and 2. We can't go any lower than that, so those are the smallest integers. So that's the balanced equation. Well done, miigwech.